Hey, it's Tony here, and I'm going to show you a video today that's processing NGC 7635 or the Bubble Nebula. This was captured using a Seestar S50 with the N.I.N.A software, and then we're going to process in Siril using StarNet and then Photoshop. I've got the image opened, and this is a result of aligning and stacking several FITS files collected over about 6 hours of time. Each file was about 20 seconds of capture using the Seestar S50. And we brought this into Siril using a script to process those FITS file that were aligned and stacked. The view that you see right now is showing a linear mode view. So that's why the image is so dark. If I go into auto stretch view, this is just a viewing mode. I haven't changed the file in any way at all. The first thing I'm going to do is I'm going to put it into a landscape view. Those that have the Siril telescope will notice that it captures in portrait mode because that's the size and orientation of the imaging chip in the Seestar. There was an icon down here. I'm going to rotate it counterclockwise or anti-clockwise. And you'll notice straight away on the edge of this image, you see some noise right around the edge. And you see a few stacking artifacts. This is where frames from different images as they were stacked may have not quite overlapped accurately or correctly. And so you see this kind of this overlap with this brightness on the edge. Also, this gradient on the edge as well can be a result of maybe illumination occurring from, say, neighbors' houses, house lights, or street lights as well. We're going to go ahead and do a crop. I'm going to hold down my left mouse button in Windows. I'm going to start about here, and I'm going to draw a rectangle like so. We'll leave it to about there. Right click, click on crop, and we've cropped the image. The next thing we want to do is do what's called a background extraction. All this does is it kind of corrects for maybe that neighbor's lights illuminations or street lights. And we go into scripts, Python scripts, and then processing. And we launch this tool here called GraXpert-AI. This is a script that I've installed into Siril. And all I'm going to do is in this dialog, I'm going to accept all the defaults and click on apply. And you see straight away we've made an impact on the background of the image. The next thing I want to do is do what's called a plate solve. I go to Tools, Astrometry, Image Plate Solver, and then click on OK. And what this will do is it simply tells Siril some of the capture parameters about the object, the focal length, and the chip size of the imaging chip, and some other information. Click OK, and you'll see that information appear on the right-hand side there for Siril. The next thing we want to do is we can then do a color calibration, and we're going to use Spectrophotometric Color Calibration. Click on that, and we can select the type of camera. So it was a one-shot color. We can select what camera. So it's the Seestar S50. And whether we used a light pollution filter in the Seestar, which we did. And so we click on OK. And you see there's very subtle color change in the image. So we can close this, and then we go into the next processing steps. One thing that imagers do or like to do sometimes is emphasize a nebula or a galaxy by reducing or de-emphasizing the number of stars in the image. And to do that, there is a number of tools you can use in Siril. And if I go to scripts, Python scripts, and go to Cycon or Cycon, you notice that there's a script there called starless Python, PY. There's also another one called RCastro Star Exterminator, which is a paid product. And then there's another free product that I use quite a bit. It's called StarNet. For this video example, I'm going to go ahead and let's go ahead and use StarNet. It's also free. Now, You could argue between the free versions and the paid versions like Star Exterminator, you get different results. Just go ahead and try them out and see what you think. So let's go ahead and use StarNet, run the script. It will then bring up a dialog box. In that dialog box, I'm going to accept the defaults up here. I'm going to, for the processing options, I'm going to select linear data. What that means is I haven't processed this image to change the brightness or the contrast in any way. And so that's why this is checked as linear data. And then what I also want is I want StarNet to create a star layer image only. So stars only image. So I select this Siril star layer D screen. So I click on OK, run StarNet, takes just a few seconds for it to complete. Close this out, and you see we've got a nice image there without the stars. The next thing I want to do is let's talk about this background. So you notice it's sort of like this weird mottling effect. It looks kind of odd and not really acceptable to the human eye. Remember, we are still in auto stretch viewing mode. So we will address this mottled effect in a few moments. The next thing we want to do is we want to sharpen the nebula area. I'm going to use my mouse button to zoom in and to scripts, Python scripts, processing, and I'm going to select Cosmic Clarity Native. So this is another script that I've also installed or added to Siril. And because I'm going to sharpen a non-stellar object, I've selected non-stellar. I'll leave the default settings at 0.5 and then just click on run. And it just takes a few moments for it to process the image. And then we are complete. And if you look, if I zoom in just a little bit more using the mouse wheel, if I do a before, and after, you can see that we've definitely sharpened areas of the nebula and potentially brought out some details. But there's also quite a bit of noise in the image as well, as demonstrated by kind of the mottled effect you see here in the nebula. I'm going to go ahead, go to scripts, Python scripts, processing, back into GraXpert. And I'm going to run the script. Brings up the dialog box again. This time, I'm going to select denoising. I'm just going to leave the defaults as is. Click on apply. This one takes a few seconds because it's kind of leveraging some AI capabilities. And so in my machine is a pretty powerful machine with a pretty powerful graphics processing unit. Hence, it moves on at a fairly rapid clip. Your experience may differ. If I do a before, you see they've got some mottling there in the nebula, and then after. So we've definitely performed some denoising there. Now, let's go ahead and zoom out just a little bit with the mouse wheel. And let's now go into linear mode. And when I do that, you can see that everything's gone super dark. There is this thing that seems to occur with Siril where the nebula seems to appear in certain parts of the image. And to get that to go away, and I don't know if it's a bug in Siril or something that I'm not doing, but if you go to image processing stretches and just select any one of these, you'll notice that that thing goes away there. And so I haven't changed the image in any way. I'm just trying to show you how to remove that part of the image before we do our stretching script. We go into scripts, Python scripts. This time, I've got a script under Verilux that's called hypermetric stretch. I'm going to run that script. It too brings up a dialog box where I can select live preview. I can select the sensor profile. And you notice that in the sensor profile, it shows the Seestar S50. And I can then zoom in using my mouse wheel again and drag using the left mouse button. This looks quite good to me, but I want to show you something. If I go to defaults, click defaults here, go back and select the S50. these default settings here of the target BG. So this is the target background, the median value for the background sky. If you look at this, if I zoom out, it's pretty mottled, even though I've kind of brought out some details a little bit. But I'm going to kind of de-emphasize this by reducing this number down to, let's go down to about 0.15 and then click on Auto Calc. So it analyzes the image data based on that change that I just made. So I've definitely kind of maybe reduced some of the mottling that you saw in the image. And if I click on Process now, Process, and close all of this, now you can see we've definitely brought out some nice details in the nebula around here. And we can do that even more. If we go to Scripts, Python Scripts, Verilux again, and choose this Python script here, Revealer. And then it too brings up a dialog box. And if I zoom in, I'm going to move this texture to about a quarter of the way across. And then let's bring up the structure just a little bit. And if I hold down the space bar, before, after. So you see a very subtle change. You don't want to go too crazy on this. In fact, if I move this all the way to the right, you see how natural that looks? It just way, way, way over sharpened or way too contrasty. So let's back this off a bit to where it was before and then click on Process. And so we've done, let's see here. So we've done the crop, remove the stars, we've sharpened the image, we've done a denoise, and then we've done a stretch on the image. And now we're going to save this. And then let's just save this basically, let's call it starless. Actually, let's call it starless 1. Just for the purposes of this demo, starless 1. Save it. And I'm going to save it as a FITS file, 32-bit. So now I want to bring the stars back in. And there's a number of ways you can do this. There is a script under Scripts, Python Scripts, Verilux, called Star Composer. That's one way of doing it. Let me show you another way. It's not any better or any worse, but a built-in one in Siril under Image Processing and Star Processing, and it's Star Recomposition. Click on Yes to close the image. And then in this dialog here, I'm going to select that background image and then the star mask that we had created. And on the star mask side, which is this area here, I'm going to select Advanced. And you see the type of stretch here is this arc sine transform. I'm going to leave it like that. And I'm going to move the stretch factor up a bit on this one, just to start to bring out some of the stars here. So you see a few stars are appearing. Maybe just stretch just a little bit more. And then click on Apply. And then the next stretch I want to do is a generalized hyperbolic transform. Click on that. And then move the stretch factors to a little bit more. And see now the stars are starting to appear. I can go really crazy here. I like really just totally blow out the image, but I want it to look natural. And so if you go to about here, that to my eye looks about right. So star recomposition is one way of recombining. There's also that Verilux script that you can try as well. It's a great thing about Siril. There's different ways of doing different things. Apply, and close. And then we can save this, and we would save it basically as a TIFF file, and would save it as 16-bit. Save here. It brings up the dialog box, 16-bit. And the reason we're saving it as 16-bit, we're going to bring this image into Photoshop. So let's cancel here, minimize this, and I've already got that image already opened, that TIFF file already opened in Photoshop. And there's a few things that we can do here. One is, if you notice up here on the histogram in Photoshop, we want to make sure that the color is balanced about right, not too blue, not too red, not too green. And if I go into image adjustments and color balance, I can kind of play around with these peaks here. We want everything to kind of center and align nicely. So let's just play around with this just a little bit. There we go. Round about there. Click OK. Now I'm using Photoshop. You can also use GIMP or Affinity. Those are free versions for doing some image processing. I just happen to have a subscription to Adobe Creative Cloud. The next thing we can do is I'm going to use my mouse wheel to zoom in a little bit. We can, if we want to, maybe bring out a bit more saturation in the image using Photoshop or GIMP or Affinity. So in Photoshop, filter, camera raw, and I can go down here, and if I want to, go really crazy and increase the saturation way too much. Let's take this back down to about 20. There's also a vibrance filter here, which kind of works on some of the saturation areas. So again, if I take this all the way to the right, you see it just doesn't look natural at all. So let's just take this to about 10. And then the other one is an effects filter, which is called clarity. If I move this all the way to the right here, it's just way, way, way too much sharpening and contrast. So let's just take this down to about 5-ish. Click on OK. And then you can see we've got a nicely processed image of the Bubble Nebula. And that's it. That's the end of the video. If you like it, please subscribe to my channel. I've got many, many more objects to show you to be processed. Thank you for your time.